Hello friends, in this session we are going to discuss a tree traversal question which came in GATE 2018. So in a tree traversal question, you need to traverse a tree, right? So in this particular question, what is given or what is required to be done is that there are two traversal orders given to you, which is a post order traversal and an in order traversal, and you need to find out that unique tree first of all, and then you need to tell that what is the height of the binary tree specified with these traversals. So as you all know that if you are given two different traversals for a particular tree, you get to know about the unique tree. You are able to construct the unique tree corresponding to them, right? So in that manner, we are going to follow the same method to construct that tree first. So I've just written the post order and the in orders over here. As you all know that a post order is left, right, root, and in order is left, root, right. So this is specified over here. Now I'm going to explain the entire method, how you find out how you construct the tree using these two traversal orders. So just pay attention and you will get through it very easily. So first of all, using this post order, we know that the last element over here will be a root because the post order is left, right and root. So the root is 1 over here. So now I just construct this node 1 over here. Now taking this 1 as the root, when I see this in order, I get to know the entire thing over here are the left hand side nodes and this is the right hand side node. So I just draw 3 over here in the right hand side branch, and in the left hand side branch I just write down all these elements in the same order, right? So now that means we have a root over here and we have a right side element. Okay, now again we look at the post order. The next root is 3, so find 3 is over here, and clearly we do not have any left child or the right child over here, so we are done with this part. Then the next root is 2 over here, right? Next root is 2. So we are going to take this 2 as the root and we are going to analyze the in order. So in the in order, we get to know that this is the right child and these are the left childs of this root 2. So we draw that graph to the next level. We draw it as 1, 3, 2, 5 is the right hand side child and the left hand side childs are over here. Again, now we check the post order for the next root. So we already have 2, again we have the 5 as the right hand side child. So we're done with this. Then the next root is 4, right? So now with 4 as the root, we check the in order traversal. We get to know that this is the right child because we are done with all the elements till here. So this becomes the right child and these become the left hand childs. So in this manner, these all become the left hand side childs or the left branch children, and this become the right hand side child, right? So again we check the post order traversal for the next branch, for the next root. So after 4 we have been given 7. Now 7 was the right hand side child, so we are done with this. The next root is 6. So with 6 as the root, we check the in order traversal. So 8 becomes the left hand side child and 9 becomes the right hand side child. So with this we obtain the complete tree. We are done with the tree. Now we need to find the height, right? So they have clearly defined what they mean from the height or which level, because now this is very important to get to know how they are considering this height, because they might propose a different definition, right? Because there comes a difference between the levels. But more generally the height remains the same. So but still, for our clarity, we'll just read the question first and then we'll get to know, then we'll find out the answer which is required in respect to it. So they state that the height of a tree is the length of the longest path from the root to any leaf. Okay, so from the root to any leaf. Now these are the two leaves, right? These are the leaves. Now more specifically, it should be the leaves at the last level, because these are also the leaf nodes, right? But we cannot say that this is the height. So there might be this might be a small mistake in the gate question, but nevertheless we know what they are trying to infer, what they're trying to state about the height of the tree. So we'll just find out the height. It is 1, 2, 3, 4. So we just count the edges from the root to the last level's leaf. If you count the edges, you get to know 1, 2, 3 and 4. So the height of the tree is 4. So that's all for this question. In next sessions, we will be discussing some more GATE 2018 questions with respect to digital electronics and data structures and algorithms. So stay tuned, and I'll see you all in the next session. That's all for this session. Thank you guys. Thank you for your support. And in case you like this video, please like it and keep subscribed. And please press the bell icon for upcoming notifications. Thank you all. Stay tuned and happy learning.